Okay, so good morning guys, no? Welcome to Process Automation 2 Control, no? AMT 421. For those who haven't enrolled yet in the U-Step, no? U-Step na course, ang ato ang enrollment key ako tong gi-post sa kuan sa Facebook, so mag-enroll na. Okay, then you may now chat your kuan, no? In the chat box your complete name and your ID number, no, for our attendance. Okay, so you could also click, no, in the synchronous class in the use step, no. Pwede na niya i-click for Zoom. Okay, so we'll be discussing no, PID control mode part 1. So ako sa stop share. I'm going to share my PowerPoint or presentation. Okay. Guys, klaro ba itong one slides? Kaning EM2 Process Automation to Control. Klaro ra? Okay, so kung makita ninyo, Mikaela, makita ra? Hello?
Yes, sir. Makita ra.
Very good. Okay. So, PID control mode, no? So, when I say PID control modes, technically it has different modes, no? As shown in the graph, no, there is no control mode, or there is proportional control. There is PI, no, combination of the proportional and integral controllers, as well as PID, no, the combination of all the controllers, the three controllers, and so on and so forth, including proportional differential, no, controllers. Now, the question is, why is it that we're going to discuss the PID control modes? Actually, as we learned, no, last sem, uh, technically, we just simply go to auto tune. No? If we can still remember, auto tune means that the PID parameters, no, is automatically tuned accordingly. But somehow, no, sometimes in a industrial na control na setting, there's no such thing as a perfect na setting, no? Perfect na system. So one way or another, sometimes there will be there is a kaning mismatch, no, sometimes the available final control element, let us say uh, the available final control element, the control valve or the proportional control valve, has a bigger size, no, in terms of the pipe diameter as compared to the existing piping. So in that scenario, no, because of the problem of the availability of the final control element, such as the proportional control valve, so there is a tendency or the decision to make na, despite that you're using an overcapacity, no, a bigger size final control element, no, but then again it's part of the management decision that you have to complete the installation. So this is the reason, no, na there will be inconsistency, no, particularly with the different parameters set by auto tune of the PID controllers. So sometimes you have to do manual, no, manual setting of the PID controllers. Okay, so this is the reason why we have to discuss this one. When that time occurs, no, scenario occurs, so you will you have the opportunity to adjust accordingly. Know how to adjust the different controllers, namely proportional, integral, and differential. Okay, so we remember, no, the block diagram for this one. We have the set point here, then the sensor feedback, then the process, then the three controllers, no? Namely proportional, integral, and derivative. So you notice that the difference between the set point and the ano, process variable output, no, as sensed by the sensor is actually the error. Then it will be, no, input sa imong three controllers, then you just simply take the sum of the three. Then you have the output. Then on the right side, it's a graph, no, showing an example of different responses of the controllers, particularly the constant, no, or the gains, no? Proportional gain, the integral gain, and the differential gain. So accordingly, KD, KP, KI. Okay? Now, if you're interested with the mathematical na after all, you have completed your calculus. So this is the equation. The U of T is the controller output, or also known as the manipulated variable, is equal to this formula. Okay, so take note that the error value is simply the set point minus the process variable value. Okay, it's just a recall. Okay, so kakita ano mo aning kuan bay Zumubot by Pulolo masiguro nga brand. Kitsa na nagakitaan eh. Hello, you there? Kita na mo ani?
Yes, sir. Kita na,
Okay.
sir.
Okay, so
Yes, sir.
actually this Pulolo na brand na Zomobot is actually particularly in line tracing, no? Sa line tracing na kanapit ang magsubay sa line. Though I haven't checked yet for the Zomo na part, wala po kakita sa Zomo na part. But for the line tracing, I'm familiar with the line tracing. It's no longer using combinational logic. Kinsa pa kadumdum sa siyang combinational logic such as and, or, not, XOR, and so on and so forth. No? So, dili na siya gagamit pag ng mga logic. No? Let's say, if we're going to use conditional statements, no? If, then magamit din kag mga and, or, and so on and so forth. So, this type of kuan, uh, Zomobot or Pololo na Zomobot, though it can perform line tracing, it's no longer using such kuan, no, and algorithm. It's using actually a PID, similar to a drone. Similar to a drone na technology is using proportional, integral, the derivative or differential controller. So I'm going to stop my share. I'm going to click this kuan, no. I'm going to click this link. Okay, stop share. So I'm going to share again the video. Where's the video? Okay, so can you see the video, guys? So if you have already downloaded kuan, the PDF file, kita ninyo? Hello?
Yes, sir.
Okay, so you notice, so you need to press the button twice. Now, during the first press is it's calibrating, no? Calibrating the sensors, the infrared, IR, the IR line sensors. After the calibration, it will now implement its PID na control. Okay, particularly on the speed, no? The speed adjustment. Okay, so I'm going to play it again. You notice that I pressed it once. Okay, so it will be moving like that so that it will calibrate its IR line sensors accordingly to determine the black from the white color, no, the plane or the platform. Okay? So inaana siya ka dali ra kayo, no? Na yun, paspas po siya. Unlike sa katong traditional na mga non-PID na mga controllers. Okay, so I'm going to stop the share. I'm going to share again my PowerPoint. Okay, so na may pangutana. Kita ba ninyo akong kuan slides? So we're going to proceed anyway. Okay. Okay, so we go now to ano, as I've said, no, PID controllers can be set, no, pwede siya mas-set into different modes. Now, ano di man ako na next. Okay, so the first setting would be the on-off control. Okay, of course, can be also set to proportional control, proportional integral control, proportional differential control, and finally the complete set, no, including proportional, integral, and differential controllers. Okay, these are the three different controllers within the PID controllers or system. Okay, so let's start with on-off PID control mode. So say on-off, it's a type of control method. It's a type of control method commonly applied to a process control that is two-position control. Uh, Way back, let us say 20 years ago, no? 20 years ago, if you're familiar, kinsa man kay taga Medina dire Fiesta taga Hingoog. Fiesta brands was once using an on-off control na kuan in their process control system, particularly for their sterilization and pasteurization and drying, no? Drying, particularly for their dried coconut or desiccated coconut. So they were using open or fully closed na pneumatic control valve. So there is no intermediate. No? So after, let us say, mga 10 years ago na, after using that control valve, duwara man na iyang position, fully open and fully closed. So na-doubt na siya. That is normally the lifetime of control valve, no? Pneumatic control valve. Basta properly maintained lang. So it is now replaced with proportional, no? Proportional pneumatic control valve. So it has an intermediate na range, no? So going back to the kung ano, aning old na pneumatic control valve, it has an output that is fully on or fully open or fully off or fully closed, 0%. So, take note that the on and off control system does not have an intermediate setting. So, wala siya tunga-tunga, wala siya tunga-tunga, almost 100%. So, duwa ra gyud. So, it's like a digital control. No? Logic 0 lang siya o logic 1. So, mura ginana. So in this example, no, so this is a water level system, no, a typical water level system, wherein you have a tank, you have perhaps a supply for the water or a pump perhaps. Then you have the controller, and you have the final control element which is a solenoid valve perhaps. You notice that there is only two, no, level of the water limits, the lower level and the upper level or high level. So if you're familiar with the solenoid valve, no, it's an electrically actuated na valve, no, that makes it solenoid, na siya electromagnet. Okay, so if it is fully open, then you allow the media, no, or the water to flow. Okay, open man. If it is closed, then you notice na closed siya. So duha lang ka mode. Usually common in the market, kung mapalit lang kang solenoid control, duha ra nakaposisyon unless it is a proportional control. If it is solenoid lang, so it's normally open and normally closed. Open and close. Now, one of the limitation in open close system kay sa graph makita ninyo open and close, open, close. So digital kay siya. Nasa gitawag na problem with the intermediate na area. So ang tawag na din na dead band. So later as you 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 go advance in the settings of the controllers na yung mga word ng mga dead band. So at least makasabot na mo what is meant by a dead band. What is a dead band? Okay. So, ito mo na siya. When the level is between the upper and the lower level sources, there is no change in the control circuit. No, wala na siya. Since there is no change, so there is no change in the final control level. For this reason, the area between the high level and the low level is called dead band. Pasabot, walay nahitabo dia in between. Walay nahitabo dead. Walay nahitabo. Okay? Walay nahitabo. Okay, so it's dead. Okay? So there is a problem, no? If the dead band is too narrow, the control elements turn off more frequently. Reduces the life of the control element. Kung papaspaso na ni mo, papaspas kay ang on off mechanical man siya. So in terms of lubrication, makaproblema gyud sa kadugayan, no? Ipaspas naman kaayo. Mana ang mga ano car engine design gina siya na magkuan gika preheating sa imong kuan no sa imong sakyanan no mga motor na para ma-circulate ang ato ang kuan oils no? So considering that it will be kuan no fast kaya ang iyang kuan pag movements. Okay, so mana tong banda yan no. If the dead band is too narrow, so paspas kaya siya. So the life cycle of your control element kagamay, no? Kagamay ang life cycle. Okay, so unsa imong buhaton? So therefore, an on-off control system should be set so that the dead band is wide enough to prevent the frequent oscillation. Okay? Para dili ra kay siya paspas. Okay? May pangutana, let's proceed. So in this diagram, gipictura niya ang the yellow portion is also the known as the dead band. No? Within the inside the rectangle is the dead band. Nga naman, kay kanira mang lower limit o upper limit ang naay kuano detection. But within the kuan within between the low and the level wala detection. Okay? So this is known as the dead band. Okay? Okay. So, familiar mo sa kuan bay sa relay logic na system? Nadumdum pa mo? Now, in between purely electronic system, if you're going to compare purely electronic system or a microprocessor system, that is purely electronics versus relay logic or using relays, no? Ano sila yung difference? No? The first difference is faster ang electronics. However, the relay system is much slower. But if speed is not the issue, if the issue is about ambient siguro na temperature, then there is a problem in dealing with electronics or purely electronic system. No? Kaya nga naman, no? Dali ra mo init ang imong electronic system if the ambient temperature is init po. No? So dali ra na siya madaot. Okay, so that's why you have to decide, no? Particularly, no, if you're going to use this kuan kining on off na kuan no butang na to water level no water level system in recovery for ano condensate no steam condensate no in a dryer system na magana return na kuan no steam condensate or condensate padong sa boiler no para mas efficient ang kuan no paspas ang aning production sa steam. If you're going to use a microprocessor based or a purely electronic system para sa katong pag-pump no automatic pumping of the condensate going back to the boiler, impas ang imong kuan, impas ang imong electronic system nga naman init man na siya di ang environment, particularly it is near the dryer no na area, impas siya dali ra na yang wear and tear. So I suggest if it is it doesn't require so much speed no, so we better use a relay based na control system. Kaya nga naman ang relay is capable of compensating ko ano init na environment. After all, metals man na halos dia ang part sa electromechanical na relay, no? Okay? So, I hope naka-remember pa mo ani na kuan man siya na cover na siya katong previous na to na klase. But we're going to review this one, but this time it has kuan new design. Particularly guys, if it is kuan food grade na system, mag-require gid siya kaning vertical float switch na stainless. At the same time, it is high temperature. Stainless are dealt for high temperature. So, okay ra. Okay? So, pwede ka makaingon that this control panel is composed of relay. No? Relay. No? Na-relays na siya. Nasa sulod. Then, perhaps kaning mga electrodes ni mo dire no, is connected to your vertical float switch. Pwede na or pwede pod na electrodes na gina siya no. Pwede ra or float na siya mga different floats. Pwede ra po. Okay? Regardless of the scenario, no, kung asa unsa man gani ang actual na scenario, similar ra gyapon sila og ladder diagram. Take note, 24 volts ni siya, but it doesn't mean na 24 volts lang atong relay. No? You could always use the 24 volts, the 12 volts, the 220 volts, the 110 volts for the control circuit. No? Pwede na inana. But never for 40. Ayan na for 40 volts. Taas sa kaya na for a control circuit. Pwede rin takutol sa 220 volts. Okay? Okay, so take note, no? In this kuan, it's using a selector switch. No? Sa iyang design, gamit sa selector switch. As much as possible, we're not going to use a selector switch. We're going to use a push button switch. But since sa amatol mo gani, ako rin ang copy and paste. Okay? Pwede man po ng selector switch. But as much as possible, mga push button ganun normally. Para dili nyo malimutan na if there will be kung ano, overload sa system, mag-break din diretso. Kani, you cannot break this one because it's using a selector switch SS1. Okay, so take note, no? When the control power is applied on the selector switch 1, the pump motor P1, so ang iyang control coil, no, padong sa imong contactor perhaps, is going to be energized. Okay? So this causes the tank to begin to fill. Notice also that the solenoid valve tube, yung aning nasa ubos final control element nato, is always energized as long as there is control power, or as long as the selector switch is in the start position. Okay? So mga na ang condition. Okay. You notice, by the way, the float switch is normally closed. The two float switches is said to be normally closed. Pag float na siya, that's the time na ma-open. Okay, so manang bantayan. Okay, so in this scenario, the water above low level. So baga ni saka na siya sa low level. So the low level float switch ni float na. So that is the reason that the LS1, low level float switch ni float na. So which means it becomes open. But since it's using an interlocking or kaning latching na design because of the CR2 no, na coil, na relay, so na-close na ni siya. So therefore, even though na-open na ni siya na circuit, there's also always continuity in the current or power going towards your pump as well as going towards your final control element, the bulb. Okay? Ayan. So therefore, the pump will always fill the tank, no? Even though that the water level reaches the low level na switch or float switch. Now, what will happen if it reaches above high level switch? So duwa na siya ka float switch ang becomes now open. So open na despite na ang imong selector switch is on as well as the CR1 is closed. dili na wala na ipadong sa imong pump. Okay, wala na current na pwede ipadong sa imong pump, but however, the solenoid valve is always energized. Open sa permente. Okay? So mga po niyang design. Okay? Okay, murang nabalik na siya. Okay, so kapangutana, nabay alternative ani na method, particularly the water control or water level or any fluid level na control system. So there is an alternative method no, to control the level that would allow the pump to run continually. So katong gi-present na to, it is actually the solenoid valve that is running or open always. No, this time the alternative is the pump would be running always when the control power is on. Okay? But instead, this time, use the solenoid valve to control no, the level. So, dili na ang pump ang mag-on o off considering na dako kay nag-power requirement ang ganang mag-on o off sa pump, no? Starting current sa imong motor, dako na siya. So, why not do the alternative, no? Which is the solenoid valve. Gamay ra na yung current requirement, no? As compared to the pump. So, therefore, mura ginani siya. Actually, mana siya. Mana siya na system. Okay? So, na may pangutana kung madunggan pa ba ko. So far, there are 32 nag attendance. Okay? Let's continue. So, familiar mo no sa atong sa to ang Panasonic na temperature controller or controller na to. Ang atong Shinko or Panasonic, pare-pareha sila og architecture. Okay? So, this previous example nato sa to ang instrumentation, no? You can always set the Shinko Panasonic controller to become on-off output mode or on-off control mode. Okay? So, particularly that it has a 12 volt na output. 12 volt yung output. So, therefore, you can use either a solid state relay or an electromechanical relay or pwede po way back katong nag-trouble mi sa katong Packmate na kanang kwan, retail na machine na familiar na sa mga kwan sa mga kape na mga machine no to retail packing na mga kape. Pare-pareha na sila. Nadaot man ang SSR, wala may choice. Wala may choice, gipulihan na mo og kontaktor balang magtingog-tingog siya no, maglamba-lamba. Just to kuan lang no, to satisfy the downtime para di wala may downtime at the machine. Then while waiting for the replacement sa kaning solid state relay. So okay? So pwede siya. Considering that na siya heating element. No? So ina siya. On and off lang ang yung design. Okay? Now, going back sa to ang programming, no? If you could still notice the last time, the kutob rata diri sa auto tune, no? Auto tune na kita kutob. No? Sa auto tune, everything is automatic. No? But this time, if we're going to set the controller into on-off na mode rather than PID na mode, or rather PI or PD, and so on and so forth, you need to go back sa kanay bitang sub setting mode na na auto tune, particularly look for the P. Now, P means proportional band. No? If you're going to set this setting, instead na by default it is 10 degrees Celsius, if you're going to set this to 0, it becomes an on and off control mode. So, mawala na to yung I, mawala na po to yung D na setting. Di na mo siya makita ang I o D or di mo siya ma-change. If you're going to set the 10 degrees to 0, if you're going to change that one. By the way, you can always download the manual ng PDF. Okay? Then, particularly, kung kadumdum mo sa katong manual, if you're going to read the manual, and 5, no? You're going to press the bottom up o kaning mode. Dunganon ani mo press. Dili ka tong up and down press, dili pa tong down o mode, or dili pa tong mode lang. So katong up arrow o kaning mode or set. Hindi kung sa to apang controller up and kaning mode or set. No? We're going to press that for around 3 seconds siguro. Pag once makasulod na kaato, no, ang una na parameters 80. So makita na din mo ning P. So set na to 0. So that's it. Nahimo na siyang on off na kuan. Control ang imong controller. Dili na siya PID. Take note, dili na siya PID no. Wala na siya P, wala siya I, wala siya D. On and off lang. Okay? So mara na siya. Then additional thing is kaning hysteresis, no? So instead na katong up and mode, diri na pud ka sa up and down, no? Particularly, what is the hysteresis? So kung familiar mo sa electromagnetism, na siya gitawag na hysteresis curve. Kato nang ihang ano, residual magnetism na concern. So kung unsa kadugay siya ah, maka-generate of residual magnetism and electromagnet. But anyway, in this hysteresis na characteristic for the on and off, no, mode, particularly kung basahon na nimo murag his, no, the setting. So, ingan siya na sets on off hysteresis for the output one. So only available for on off na control. So by default, ang hysteresis niya is 1 degree. So pasabot, if there will be 1 degree change, no, kanay bitaw high o low, 1 degree change from the set point, that's the time na mo change ang iyang kuan. Magsaka naog na siya. Mo to get for example bitaw sa dead band, no, na magkuan siya up, down. So if you're going to change this into very small, paspas siya magkuan, paspas siya mag up and down. Kaya nga naman, mas buta na to 0.01 or something, no? Very small changes in the temperature, mag-pulsating na siya, pasaka up and down. So if the final control element is electro pneumatics na kuan, control valve, dali ra na madaot. Kay mechanical man siya in nature. Okay, so manang bantayan ninyo ng hysteresis, dili ninyo ni kayo ipaubos, no? As much as possible, default na na value, or you can increase, no, accordingly, para ang pagsaka niya ang pagnaon dili ra kay paspas. Okay. By the way, nalimtan ako, the on and off na kuan na control mode is if we're going to apply that in the flat iron or plansa, no, equivalent na sa gitawag na thermostat. Okay, thermostat. Ang inyong plansa, inanam na siya, dili na siya proportional ang iyang kuan, iyang pagsaka sa init o pag-increase sa kainiton o pag-decrease. Kuan na siya, on and off na siya na example. Nagamit na siya og thermostat. As well as ang ganang mga heaters, no, inaana na siya, on and off na siya, ang mga water heater, much more ganing air conditioning system. Gamit na siya og thermostat. Kaya nga naman, kung ang imong gamito na PID, kuha na ka siya, overkill na ka siya, no? Kay kung pabugnaw lang sa kaning isa ka room, no? Dili man kay sensitive ang tao sa kanang gamay lang na degree na difference. Particularly, the hysteresis is 1 degree. Di kayo na manotice by particularly kung 18, 17, 18, 19. Di kayo na manotice. So that's why it's an overkill to use a PID controller for kaning mga air conditioning system for our room. Pero kung magamit na mo ka ng mga product na mga ano, cooling system sa mga product, na let's say it's going to maintain 1 degree, para yatang the last time na coconut water, yung Vita Coco, kung familiar mo na, kinanglan na siya 1 degree na requirement. Okay, so it will be using a PID na control system. Dapat ma-maintain gina niya 1 degree. Okay, unlike sa kaning typical na plansa, heater, So it's using a thermostat on and off lang na system. Okay. Then sa gingon ko pa no, dunganon daw ni pislit ang up o down sa to ang Shincore Panasonic na temperature controller until makita niyo tong hysteresis na part. Okay? So if you're going to change of course. Okay? So na may pangutana na, guys.
Subtanner so far, sir.
Okay. Next time na lang to mag-present sa itong next na topic. Do ako to i-continue but it seems na marag ano to ulit tayo sa kauras. Okay, so kung wala na may pangutana, ako na ni-stop recording. Ano na stop recording? Kung i-stop recording na ako, dili na maka-attendance. So, kitsa mo itong wala maka-attendance. So far, murag 36 ang makita na ako sa chat or mga or less. Attendance na mo guys before na ako i-stop recording. Kaya ato na lang po i-share ato ang PowerPoint. Dili di. Ano na lang. Ano na siguro. Okay? Okay, napagi nagpahabol, oh. Pahabol attendance. Pahabol attendance. Buda ko mga 35 ba siguro. Ano naman tayo nag-chat the last time. Apple siguro nag-count. So far, 39. Actually, this lecture is intended for 2 sections. So, dapat, kung ano, sobra ni sa unta sa, doon ni mga 80 siguro. But anyway, I'm going to post this right away. After na ma-store na sa cloud. I'm going to post this right away. Okay, so wala na yung magpahabol ng attendance. Okay, murag wala naman no. So, stop recording na ta.